Okay, welcome to John Stewart's Calculus Early Transcendentals 9th edition. Carolina's requested I jump forward and solve problem 53, and it's a terrible problem, thank you very much for that. You have to know a bunch of math tricks and kind of just have some math intuition, so let's jump right into it. And by the end of this, you'll be a mathematician and be able to just pull numbers out of thin air. Alright, so the first question, the first step is always figure out what the question is asking for. It just wants to take the limit as x approaches 0. But there's two things you need to know how to solve this problem, and the first one is that there was a limit given earlier in the chapter that basically says the limit as x approaches 0 of sine x over x is equal to 1. Okay? Now, if we were to replace x with, say, 3y's, because it's just a variable, as long as we say that 3y equals x, it's still true. So we can also say that the limit of y as it approaches 0 of sine of 3y over 3y is also equal to 1. The reason we're going to need that is because if you look at our problem, we have that ugly sine 3x on the top. But we don't really have a 3 on the bottom. So eventually we're going to both try to get an x on the bottom and try to get a 3 on the bottom in order to make our limit kind of look like limit as y approaches 0 of sine 3y over 3. So, you can justify this in your head if you need to. You can think about it. 3 times 0 is still 0. So the bottom, you basically would still get 0. And on the top, if you take the sine of 0 or you take the sine of 3 times 0, it's the same thing. So that's kind of like a quick little proof that, yes, this limit that I'm applying, this trick, is actually true. Alright, so my general approach is basically we're going to try to think about how we can separate this in two limits and see if we can make one of them look just like our identity. So on the top, we have that sine 3y identity, and we have this one that we just kind of established here. So at the first difference, what's different at the first glance? Well, you can see with our problem, we don't have an x on the bottom. So is there some way that we can simplify our problem to make an x appear? Can we do anything like extract an x out on the bottom? And the answer is yes. Both terms, if you look at it, the 5x cubed and the 4x have an x. So we're just going to factor that out here. So hopefully everybody followed that algebra. All that I did is I just removed an x from the 5x cubed, which made a 5x squared, and I removed an x from the minus 4x. Alright, now let's start to look closer at identity, and I'm going to separate this into two limits now, just to make it a little bit easier. Alright, so it's now two limits. Now if you look at this limit here, right, what is different between the limit we have up on the second line, or sorry, the first line I guess, and at the bottom here? Is there anything different between those two? Well, if you look, you'll notice that what's missing is that there's no 3 on the bottom. Right, when you compare these two limits, what is different? One of them has a 3x on the bottom, and one of them has just an x. So the question is, how can we pull a 3 out of thin air, right? So basically, like a magician, what if I were to multiply this limit by 1? Would you agree that if I multiply by 1, the value doesn't change? Right? But then the question is, how about if I multiply with something with the value of 1? Is it still the same? So instead of multiplying by 1, I'll just multiply it by 3 over 3. Right? It's just a constant. And multiplying by 3 over 3 is the same as multiplying by 1, so I haven't changed the value. And then I take that little 3 on the bottom and I just move it inside. Now if you look, it's starting to look a lot like our formula, right? So now we know that the limit as x approaches 0 of sine 3x over 3x is equal to 1. So everywhere where we see that in our equation, we just simply replace it with a 1. That's kind of what that little arrow is indicating. On that step, the entire limit is just being replaced by 1. And now I apply the limit as x goes to 0 to the second term, which means everywhere where there's an x in that expression 1 over 5x squared minus 4, I'm just replacing with a 0, which is pretty simple. And then I'm just doing some basic math. So of course, 0 squared is 0, multiplied by 5 is also 0, and then 0 minus 4 is going to give you a negative 4 on the bottom. So you end up with a negative 1/4 in that fraction. And then of course we still have the 3 and the 1 on the outside. If you multiply 3 by 1 by negative 1/4, you just end up with negative 3/4. So basically the entire limit comes out to negative 3/4. Yeah, that's it. If you hopefully you like that problem. If you're looking for a solution to another problem, you want me to jump ahead to a specific problem you're having trouble with, just let me know which one and I'll do my best to solve it. And please consider liking this video so other people get a chance to see it. Thank you. Goodbye.